Hello, I'm Ed Murphy with the Astronomy Department at the University of Virginia, and this is my lecture, Are We Alone? The Search for Extraterrestrial Intelligence and the Fermi Paradox. I think that one of the most important questions that we are asking in astronomy today, and in fact in all of science, is are we alone? Are we the first intelligent species in the Milky Way Galaxy? Are we the only intelligent species in the Milky Way Galaxy? I want to answer these questions, or at least examine these questions, through the lens of the Fermi Paradox. To get started, let's talk about our galaxy, the Milky Way. This is an image of the Milky Way Galaxy taken from Mount Graham in eastern Arizona. It's an example of what you should see under beautiful, dark country skies. The sky should be filled with thousands of stars, and cutting across the sky should be that milky band of light, which is the galaxy that we live in, our galaxy, the Milky Way. In addition to the Milky Way and the stars, we see a planet in this picture. We see some trees along the horizon. We see the city lights from Phoenix, Arizona and Tucson, Arizona, many hours drive from Mount Graham. And cutting across the middle of the field here, this is the Milky Way. Now, many people wonder, why does the Milky Way look the way that it does? Why does it look like a milky band cutting across the sky? Well, if we could get outside the galaxy, it would look like this. Our Milky Way is a thin, flat, spinning disk that has a large ball of stars down at the center called the galactic bulge. We live about halfway out in the disk, and we live about halfway between the top and the bottom. The analogy that I like to use is our Milky Way Galaxy is like a pizza. It is round. It is thin. It's like a pizza that has a giant watermelon down at the center of it, and that giant watermelon is the ball of stars. Now imagine living in the pizza, halfway between the top of the pizza and the bottom of the pizza. When you look above you, there's not much pizza above you. When you look below you, there's not much pizza below you. But when you look around you, there's lots and lots of pizza. And when you look in one particular direction, then you see the giant watermelon that is down at the center of the pizza. That is our Milky Way Galaxy. There are not many stars above us in the Milky Way. There are not many stars below us in the Milky Way. There are lots of stars around us in the Milky Way, and then if you look in the right direction, here in the northern hemisphere in the summertime towards the constellation of Sagittarius, you can see the galactic center, the huge bulge, that giant watermelon of stars down at the center of our galaxy. With the naked eye, you can even see giant clouds of gas and dust cutting down through the center of our galaxy. These clouds of gas and dust block our view of distant stars, and they split the Milky Way into two distinct parts. Now, we'll begin our discussion of extraterrestrial intelligence and the Fermi Paradox by talking about our galaxy. And there are two facts that I want you to know about the galaxy, and we'll examine each of them in turn. The first one is that our galaxy contains a phenomenal number of stars, about 200 to 400 billion stars. And we'll put that in perspective here in a second. The second fact that I want you to consider is that our galaxy is ancient, between 12 and 13 billion years old. And I'll try and put that in perspective as well. But many people, when we start the discussion of the search for extraterrestrial intelligence, will argue that we cannot possibly be alone in the galaxy because there are so many stars in the galaxy. And the argument that they're using is essentially the Drake equation. The Drake equation is an equation developed by the astronomer Frank Drake as he was preparing for a meeting of scientists, in fact, the first meeting of scientists to discuss the possibility of communicating with an extraterrestrial civilization. He wanted a way to organize the discussion, to organize their thinking around the question of, are we alone in the Milky Way Galaxy? And he developed an equation that simply tells you that the number of communicating extraterrestrial civilizations is related to the number of stars in our galaxy times the fraction of those stars that have planets times the number of Earth-like planets in each system times the fraction of those Earth-like planets that develop life times the fraction that develop intelligent life times the fraction that develop the ability to communicate, and it depends on how long the civilization lasts. Let me give you an example of this. I'm going to simplify the Drake equation here very simply. Let's assume that our Milky Way galaxy contains about 200 billion stars. I think that's a very reasonable estimate. The galaxy is somewhere, typically you'll hear it stated between 200 and 400 billion stars. So let's go on the low end of that just to be conservative and say that our Milky Way galaxy has 200 billion stars. Now, we believe that in order to have life, it has to be a sun-like stars. Very massive stars live short lives, and in those cases, there's not enough time for intelligent life to develop. Very, very low mass stars, the planet has to be very, very close to the parent star in order for liquid water to exist on the surface, in order to be in the habitable zone. And in those cases, those planets are likely tidally locked to the star. So we're probably looking at a limited class of stars that are around the same size and mass as our sun. And as just a rough number, and a number to make the math work out easy, let's assume that about 1 in every 10 stars is like our sun. And that's not a bad estimate. That means if there are 200 billion stars in the Milky Way galaxy, there are about 20 billion sun-like stars. Now, the evidence we have today from the Kepler mission, from TESS, from other searches for extrasolar planets, we believe that the vast majority of stars have planetary systems. So it's likely that most, if not all, of these 20 billion sun-like stars have planets going around them. Now, I'm not talking about Earth-like planets yet, or Earth-sized planets. I'm just talking about planets as a whole. But again, let's be conservative. And let's assume that only 1 out of every 10 of these sun-like stars has planets. And so if there are 20 billion sun-like stars, that means there are 2 billion sun-like stars with planets in our Milky Way galaxy. And again, I'm just saying 1/10 because it makes the numbers work out nice. Now, of these 2 billion sun-like stars with planets, the question is how many of them have an Earth-like planet? And that's a question that is not yet answered in astronomy today. We know that Earth-sized planets are common. Earth-sized planets in the habitable zone around their parent stars are common. The habitable zone is that region around the star where you're not too close to the star and too hot for liquid water to exist, and you're not too far from the star where it's too cold for liquid water to exist. The habitable zone is that region where a planet can have liquid water on the surface. But how many of these planetary systems contain an Earth-like planet, we just don't know. So for just the purposes of argument here, let's assume that it's 1 in 10. Of these 2 billion sun-like stars with planets, let's assume that 1 out of every 10 of those have an Earth-like planet. And that means that there are 200 million sun-like stars with Earth-like planets in our Milky Way galaxy. Now, not every one of these Earth-like planets will necessarily develop life. We know that on Earth, when the conditions were right, life developed fairly quickly. That leads me, at least, to believe that life probably arises naturally and quickly on planets on which you have liquid water on the surface. But you can make arguments that possibly the origin of life is rare. So we don't know how many of these Earth-like planets will develop life on them. The only example we have is our own planet, Earth. But for now, let's go back to our standard 1/10 and say out of these 200 million sun-like stars with Earth-like planets, 1 out of every 10 of them will develop life. That means there are 20 million sun-like stars with Earth-like planets with life in our Milky Way galaxy. Now let's assume that, well, astronomers don't know and biologists don't know, just because you have life, how often do you get intelligent life? So of these 20 million sun-like stars with life, sun-like stars with Earth-like planets with life on them, how often will one of those planets develop intelligent life? And the answer again is that we just don't know. We just don't know whether intelligent life is rare or whether it's common. So for now, let's go back to our 1/10 and say of these 20 million sun-like stars with Earth-like planets with life, 1 out of every 10 of them will develop intelligent life. And that means there could be 2 million sun-like stars with Earth-like planets with life that develops intelligent life on them. Ultimately, the Drake equation is an equation about numbers, and it starts with an incredibly large number, 200 billion stars. And that leads many people and many scientists to believe that life in the galaxy must be common, because there are simply so many stars out there that even in this case, if you keep eliminating them and only keeping 1 out of every 10 and 1 out of every 10 and 1 out of every 10, you can still end up with an argument that there could be many intelligent civilizations in the galaxy. It's important to know that the Drake equation is not meant to come up with an absolute number of the number of intelligent civilizations in the galaxy. I think people who say that mischaracterize the use of the Drake equation. It's not meant to calculate specifically how many intelligent civilizations are out there. I think it's really more of a tool to organize our thinking about it. But regardless, it seems that given the phenomenal number of stars in our Milky Way galaxy, that life in the galaxy must be common. Now let's put that fact aside for a second, and let's talk about something else about our Milky Way galaxy, and that is that our Milky Way galaxy is ancient. Our Milky Way galaxy is 12 to 13 billion years old. Now, how do we put that in perspective? Because that is such a long period of time that no one can comprehend a vast period of time like that. Carl Sagan, in his television series Cosmos, tried to get a handle on this by developing something called the cosmic calendar. And the cosmic calendar has the Big Bang on January 1st at midnight, and it has right now the current moment in time on December 31st at midnight a year later. Because see, a year is a period of time that everybody can understand. Everybody knows what a year looks like. Everybody knows the length of time of a year. And so what if we take the 13.8 billion year history of the universe and cram it into 1 year? That's a way that we can think about these timescales that are involved. And so I'm going to use the cosmic calendar that was developed by Neil deGrasse Tyson in his remake of Carl Sagan's Cosmos series. In this cosmic calendar, the Big Bang happens on January 1st. So January 1st is the day of the Big Bang at midnight. The first stars show up about January 13th on the cosmic calendar. That's when we get the first stars in the universe. And the first galaxies show up on about January 16th in the calendar. Now, these first galaxies were much smaller than our Milky Way galaxy. Large galaxies like our Milky Way took some time to form. And in fact, our Milky Way galaxy probably formed from cannibalizing and merging with smaller galaxies, and that took a few billion years. Our Milky Way galaxy really didn't finish forming until about the middle of March on the cosmic calendar. Now, from the Big Bang until the present day is 13.8 billion years. That is a hard-won number by astronomers. It is a number that we've been working on for about 100 years, and thanks to satellites like NASA's Wilkinson Microwave Anisotropy Probe and the European Space Agency's Planck satellite, we've now determined the age of the universe with an uncertainty of less than 1%. Our universe is 13.8 billion years old. And that means on this calendar, each month on the calendar is a little bit more than 1 billion years. So if our galaxy comes about on about March 15th, it means that it took our galaxy a couple billion years to form. So that is how long it took our galaxy to form. Now, people are surprised to find out that the Earth and our sun were not made as part of the Big Bang. They were not in this first generation of stars. They were not formed when our galaxy formed. In fact, the Earth and the sun are 4.5 billion years old. And on the cosmic calendar, 4.5 billion years old means that they were born about 4.5 months ago. And that puts the formation of the sun and the Earth right around September 1st on the cosmic calendar. Now, our galaxy was not quiet from March 15th until September 1st. There were generations of stars that were being born, living out their lives and dying, stars being born, living out their lives and dying, stars being born, living out their lives and dying, stars being born, living out their lives and dying, until finally our sun is born on September 1st. And our solar system, the Earth and all the planets, formed with the sun. Now, initially, the Earth was unsuitable for having life on the surface. It was very hot. A Mars-sized body, shortly after the Earth formed, a Mars-sized body collided with the Earth to form our moon. There was a period of heavy bombardment in the solar system when we were cleaning out all the debris left over from the formation of the planets. But as soon as the Earth settles down and becomes quiet, life appears quickly on the surface of the Earth. By September 28th, on the cosmic calendar, we have our first evidence for life on Earth. Now, this first life was simple. It was chemosynthetic life. It did not use photosynthesis. It did not use light from the sun to generate its energy. It very likely used chemosynthesis, synthesizing energy from chemical reactions. And these early organisms probably lived around volcanic vents down at the bottom of our ocean. These volcanic vents would spew out minerals and chemicals that these microorganisms could live off of. The first photosynthesis doesn't come along until October 2nd, a few days later on the cosmic calendar. In part, that's because photosynthesis is a complex series of chemical reactions. And it took life some time to develop, to evolve those complex chemical reactions. Now remember, at this point, we're still talking about single-celled organisms. This photosynthesis is going on in single-celled algae living in the oceans. Now, these single-celled algae are bringing in carbon dioxide. They're giving off as a waste product oxygen, and so oxygen starts to build up in our atmosphere. And on the cosmic calendar, we get significant amounts of oxygen in our atmosphere for the first time on October 26th. And that's important because that makes more complex cellular life forms possible, because they can now get nutrients out of their environment and use the oxygen in the atmosphere to oxidize those nutrients and generate energy that way. Well, let me clear the screen here, and let's talk about the next major development is eukaryotic life on November 9th. The first life on Earth was prokaryotic, very simple cells. You and I, our cells are eukaryotic. They're complex. They have a nucleus. They have individual organelles. The first complex cells on our planet don't appear until November 9th. And remember, at this point, life is still single-celled. We're not talking about multicellular life yet. We're not talking about animals. We're still talking about single-celled life. In fact, the multicellular life doesn't arrive until December 5th on our cosmic calendar. Look at the history of the universe. The Big Bang is on January 1st. Our Milky Way forms on March 15th. The Sun and the Earth form on September 1st. The first life on September 28th. And then all through October, all through November, and through early December, the only life that existed on Earth was single-celled organisms. Single-celled organisms have existed on Earth for billions of years before we get multicellular life. And today is December 31st, which means that multicellular life is relatively recent. In one of the most amazing events in the history of life on Earth is the Cambrian explosion. And that happens on December 17th on our cosmic calendar. The Cambrian explosion has nothing at all to do with an asteroid impacting the surface of the Earth. In fact, the Cambrian explosion is an explosion of diversity of life on the surface of the Earth. In the Cambrian explosion, life diversifies very, very quickly. And all the phyla that exist on Earth today were created in the Cambrian explosion. For example, the phylum that contains human beings, you and I are in the phylum Chordata because we have a spinal cord running down our backs. We see in the Cambrian explosion the very first chordate, the very first animal that had a spinal cord. Every phylum that exists on Earth today was around at the time of the Cambrian explosion. And in the Cambrian explosion, lots of phyla that were created that have since gone extinct. But since that time, no new phyla have developed on the surface of the Earth. If you're interested in a great book about the Cambrian explosion, I highly recommend Stephen Jay Gould's Wonderful Life. It's a fantastic book, not only about how science works, but about what happened during the Cambrian explosion. Truly one of the most amazing events. And by event, I mean it happened over a long period of time, but one of the most amazing events in the history of life on Earth. The dinosaurs come about on December 25th. On Christmas Day, we get our first dinosaurs. And the dinosaurs do great on the cosmic calendar. They last 5 whole days because they don't go extinct until December 30th. Now look at the cosmic calendar. We think of the dinosaurs going extinct as long ago, far back in history. But on the cosmic calendar, the dinosaurs went extinct yesterday. To actually understand human history, we have to look at just the final few seconds of the final day. Early hominids evolve around 9 p.m. on December 31st. Modern humans evolve around 2 minutes before midnight on the final day. Agriculture arises about 25 seconds before midnight. The pyramids were built 11 seconds ago. 1 second before midnight on the cosmic calendar on December 31st, Kepler and Galileo showed definitively that the Earth is going around the sun and it's not the other way around. And then 1 second after that, which is about 400 years after that, we get today. 1/10 of a second is about 40 years on the cosmic calendar. So a typical human lifespan is about 2/10 of a second on the cosmic calendar. So we've got these 2 interesting facts about our galaxy. There are hundreds of billions of stars in our galaxy, and our galaxy is incredibly ancient. Let's bring these 2 facts together to talk about the possibility of other intelligent civilizations in the Milky Way. And we're going to do that using an idea that's been thought of by a number of different people over the decades, but is often credited to Enrico Fermi, although he wasn't the first and he wasn't the last to come up with it. It is today called the Fermi paradox. Enrico Fermi is one of the greatest physicists of the 20th century. He worked at the University of Chicago. He was instrumental in developing the atomic bomb. Under the football stadium at the University of Chicago, Enrico Fermi and his colleagues carried out the first splitting of the uranium atom, the first controlled fission reaction. After the war, Enrico Fermi and his colleagues were working at Los Alamos National Laboratory. And one day they were discussing an interesting series of events that were in the news. One of the events was that trash cans were disappearing out of New York City. And another event in the news was that there was a rash of UFO sightings across the United States. And what they were particularly discussing was a cartoon that appeared in the New Yorker magazine that seemed to nicely explain both of these things. It explained the rash of UFO sightings and why the trash cans were disappearing. Now, they laughed about this. They didn't think it was a serious explanation, but they did comment that sometimes in science, when an explanation can explain 2 wildly different things, that there's some validity to it. But I don't think they took this idea seriously, that the trash cans are being taken by extraterrestrial civilizations. But it did lead them down the line of questioning, of wondering whether humans would ever be able to travel faster than the speed of light. So they talked about this for some time, and they left, and the conversation died off. But after it died off, Enrico Fermi began thinking. And Enrico Fermi realized that in the size of our galaxy and with the age of our galaxy, if you could travel at 10% the speed of light, just 10% the speed of light, it takes 1 hour on the cosmic calendar to travel from one edge of the Milky Way Galaxy to the other edge of the Milky Way Galaxy. Our Milky Way Galaxy is 100,000 light years across. It would take 100,000 years traveling at the speed of light to go from one side of the galaxy to the other side of the galaxy. At 10% the speed of the light, it would take 1,000,000 years to travel from one side of the galaxy to the other. But on the cosmic calendar, 1,000,000 years is about 1 hour. And what Enrico Fermi realized is from the time that our galaxy formed on March 15th, there has been lots and lots of time for intelligent civilizations to develop in the galaxy. There are lots and lots of stars around which they could develop. And those intelligent civilizations, well, they've had lots and lots of time to travel through the galaxy. So Enrico Fermi stopped and he looked at his colleagues and he asked, where is everybody? If our galaxy has hundreds of billions of stars and life is common in the galaxy, and if our galaxy is ancient, then it appears that we should have been visited many, many times over the history of the galaxy. That is, we should not be alone in the galaxy. We should know, or at least have evidence, that the Earth has been visited by other intelligent extraterrestrial civilizations. This paradox is called the Fermi paradox. On the one hand, it seems like life is common and the galaxy is ancient, and that some intelligent civilization must have developed in the past. Maybe many intelligent civilizations developed in the past, and they have had plenty of time to conquer the galaxy, to visit all the planets across the galaxy. And yet, it appears to us that we are alone in the galaxy. So what is the solution to this paradox? Now, a number of solutions have been proposed to the paradox. I am going to talk about just a couple of these solutions. These solutions are not unique to any one individual. They've been written about by many people, but I take them from a book called 50 Solutions to the Fermi Paradox. So let's talk about the first of these solutions, and that is they are here and meddling in human affairs. Maybe it's not a paradox at all. Maybe we are being visited by extraterrestrials. After all, aren't there pictures of UFOs? And more pictures of UFOs. And more pictures of UFOs. Is this the evidence that we need to prove that we're being visited by an extraterrestrial intelligence? Is it not a paradox at all? Are they really visiting us? Well, as a scientist, I have to take a look at the UFO phenomenon through the lens of the methods of science. And one of the methods of science was given to us by the Scottish philosopher David Hume. David Hume lived from 1711 to 1776, and he provided a means for us to analyze miraculous or incredible claims. This is a miraculous or incredible claim, the fact that we are not alone in the universe and we are being visited by extraterrestrial intelligence. And here's what David Hume had to say in 1758. So keep in mind, this is not a recent development in the history of science. This is a development that's over 250 years old. That no testimony is sufficient to establish a miracle unless the testimony be of such a kind that its falsehood would be more miraculous than the fact which it endeavors to establish. He goes on to give us a really nice example. When anyone tells me that he saw a dead man restored to life, I immediately consider with myself whether it be more probable that this person should either deceive or be deceived, or that the fact which he relates should have really happened. I weigh one miracle against the other, and according to the superiority which I always discover, I pronounce my decision, and I always reject the greater miracle. If the falsehood of his testimony would be more miraculous than the event that he relates, then and not till then can he pretend to command my belief or opinion. Now, I don't necessarily like his use of the word miracle in this case, but what he's really saying here was summed up very, very nicely by Carl Sagan in a very pithy statement. Extraordinary claims require extraordinary evidence. If you are going to make an extraordinary claim that we are being visited by extraterrestrial intelligence, and they are flying spaceships to the Earth and landing here on the Earth, that's an extraordinary claim. It requires an extraordinary body of evidence to back it. Because what I have to do is I have to weigh the evidence and I have to weigh the statement that the person made. And I have to reject the one that is less likely. I have to reject the one that is less likely to be the truth. And so when I'm faced with photographs like this, is this real? Is this evidence that we're looking for? Or could this person be faking the evidence? Is the evidence so overwhelming? I have to argue from the photographs, no, it is not overwhelming. And I'll talk a little bit more about this here in a second. And I have to say, one of the reasons that I don't think the evidence is overwhelming is, first of all the pictures that I've shown you so far have come from a single individual. His name is Paul Villa. Paul Villa is probably the most prolific of all the photographers of UFOs. He claimed that they would telepathically communicate with him, and he would know exactly when and where to go to photograph them. But today, with modern photographic analysis, we can actually look at many of his photographs and we can see that I believe the evidence points very clearly that many of his photographs were faked. You can see wires in some of the photographs. In other photographs, the spacecraft are sitting on the ground. They're far too simple. They look out of scale compared to their surroundings. They look like they're little models as opposed to giant spaceships. There's something else that I find very, very interesting about the UFO phenomenon. And I think it tells us a lot more about us than it tells us about extraterrestrial intelligence. And that is that apparently the builders of UFOs watch our Hollywood movies. If you look at UFOs in the 1950s and 60s, they were sleek, they were shiny, they were aerodynamic. They looked like the UFO in the 1951 movie, The Day the Earth Stood Still. That is, in the 1950s and 1960s, the UFOs that people photographed in the sky looked like the UFOs that were in our movies. And what I really find surprising is now that our movies have changed and spaceships look different today, when you go on the internet today and find photographs of spacecraft that people report today, they look different. They're no longer sleek and smooth and shiny. They now look like the spacecraft in our modern day movies. The builders of UFOs watch our movies, and apparently they change the shapes of their UFOs to match our movies here on Earth. I think, of course, what's really going on, and is far more likely, is that when people decide to fake a UFO, and these images that I'm showing right here, these come from a YouTube video that has almost 20 million views. It's called UFO over Haiti. We know this is faked because the producer of this video has admitted that it is a faked video. But these videos show that the makers of these videos often look at the aesthetic of the time, and they design their UFOs around things that people believe at that moment in time a UFO should look like. But as our tastes change, apparently the UFO designs change as well. I think another concern that I have about UFOs is very nicely demonstrated by one of the more famous UFO incidences in the last 20 years, and that's the Chicago O'Hare International Airport UFO incident on November the 7th of 2006. At about 4:30 p.m. in the afternoon, 12 employees of United Airlines reported seeing a saucer-shaped object hovering just below the clouds, and they saw it accelerate up into and disappear into the clouds, hovering over Concourse C at Chicago O'Hare International Airport. Now, these were all reliable witnesses. There were pilots involved in this. There were flight attendants involved in this, ramp agents. Altogether, as I said, 12 employees of United Airlines saw this thing in the sky. Now, these are not people who would joke about aviation safety. These are people who've made a living by making aviation as safe as possible. The question is, what did they see that day? Did they actually see a UFO hovering over Chicago O'Hare International Airport? I have to say, to me, there's something suspicious about the Chicago O'Hare Airport. And I don't mean it to say that the people made this story up. What I'm saying is that other people probably saw what they saw and they did not interpret it the same way. And what makes me think that is what do I think is suspicious about the Chicago O'Hare UFO sighting? Well, it's the answer of where and when it took place and the number of people that saw it. This is November of 2006 outside O'Hare International Airport. At the time, I believe the second busiest airport in the United States and one of the busiest airports in the world. At that moment in time, there were tens of thousands of people inside O'Hare Airport. There were thousands of people working outside on the grounds of O'Hare Airport. It was 4:30 p.m. in the afternoon. A number of major highways in the city of Chicago run right past O'Hare International Airport. One, in fact, runs right through the airport. And no one saw the UFO except 12 employees of United Airlines who all happened to be in the same area of the airport at the same time. What's suspicious to me is that no one took out a camera and got a photograph of it. Of the thousands of people who were there, no one took a photograph. See, today, almost everybody is carrying with them a high-quality camera. Now, I will give you that in 2006, the iPhone had not been invented yet, or at least it had not been released to the public yet, but cameras in phones were quite common. Cameras, of course, were common in 2006. I think today, one of the biggest arguments against the existence of UFOs is that we don't see more photographs of them. There are people who believe that we are being visited by UFOs on a daily basis. In fact, a Harvard psychologist believed that UFOs were routinely abducting people from their homes, that millions of people, possibly every year, were being abducted and taking aboard UFOs and having experiments carried out on them. How can this be happening to millions of people in the United States every year, and no one gets a clear photograph of it? Not one clear photograph. Let me give you an example of something that very rarely happens. And thank goodness it very rarely happens because it's tragic. But when it does happen, people have the presence of mind to get out a phone and take a photograph of it. And that thing that rarely happens, but people often get a photograph of it, is when airliners crash. When airliners crash and people look up in the sky and they see an airliner coming down, they will very often take out a camera and snap a photograph of it. It doesn't happen with every airliner disaster, but it happens with a remarkably large number of airliner disasters. Because it is such an unusual event, because it is such a rare event, and because it is so tragic, people have the presence of mind to grab their camera and get a picture of it. In my opinion, if UFOs were really visiting us all the time, every day, we would have millions of high-quality, clear images of UFOs. And we don't. We don't. We have much better pictures of airliner disasters, and in the world, typically one airliner crashes every year, and we've got lots of pictures of them, and yet we don't have the corresponding pictures for UFOs. That, to me, is suspicious. But let me also point out that this means that Bigfoot probably doesn't exist. Why don't we have any clear movies? Why don't we have any clear videos of Bigfoot? People are reporting Bigfoot sightings all the time. Where are the movies of Bigfoot? What about the Loch Ness Monster? It's a very popular tourist attraction. Why aren't there hundreds, if not thousands, of movies and images, clear movies and images of Bigfoot? What about fairies or elves or leprechauns? Why don't we have images and movies of them? The answer is we don't have images and movies of them because they don't exist. I also think today, with editing, video editing software, that we're going to have to take a much harder look at photographs and videos of UFOs. This particular one that I'm showing here that I showed a few seconds ago, this one's rather famous because the person who produced this video, I would argue did a really, and this is coming from someone who is not an expert in editing videos, I thought did a really good job of putting it together. It looks very realistic. But when you read some of the articles of people who analyzed it in details, you see that in fact the video editor made a few mistakes, and those mistakes showed up to people who are well versed in video editing. One of the mistakes, for example, that appears in here is there's a particularly distinct palm tree, and it appears over and over again in the video. And that's because they used essentially cut and paste to cut and paste the same tree multiple times in the video. And as I said, the producer of this video has since admitted that it was made as a social experiment, that it is a fake. It does not demonstrate an actual UFO. But nevertheless, it's getting harder and harder these days as video imaging gets better and better to tell real images from fake images. Now, I know you might be saying, now wait a second, didn't a UFO crash in Roswell, New Mexico in 1947, and the U.S. government recover pieces of those? In fact, not only did they recover pieces, didn't they recover an alien? And didn't they conduct an autopsy on that alien? Well, the famous autopsy, alien autopsy video, there's lots of reasons to believe that the alien autopsy video is a fake. A number of things happen during the autopsy that are quite suspicious. Think about what's going on here. This is the first time that human beings have had the opportunity to autopsy an alien. For the first time in human history, we're going to get to see the interior of an alien. What organs do they have? Are their organs organized the same as ours? Do they have organs that we don't? What's the function of each of their organs? And there's just a tremendous number of questions that could be answered by an autopsy like this. Any scientist conducting an autopsy like this would take their time and be careful and document and record everything that happens. But what happens in this autopsy video? Well, the prosector very quickly cuts the alien open and starts pulling organs out and plopping them in little metal bowls. They don't seem to be paying any attention at all to how the organs are interconnected with one another, what functions the organs might play. In addition, as the prospector makes the cut on the alien, they make the cut very gingerly, and that is not how autopsy cuts are done. In the video, they use a pair of scissors, and they use the scissors incorrectly. They use the scissors like you and I would use scissors. When I cut with scissors, I use my thumb and my forefinger to cut with the scissors. But that's not how medical professionals are taught to use scissors. They use their thumb and their middle finger so that they can use their index finger to stabilize the blade. So there is evidence in this video that it is faked. Since that time, the producer of the film has admitted that at least some of the film is fake. Other investigators have found the special effects artists that produced the alien bodies for the video. They have even identified the butcher that sold the producer the entrails that were stuffed inside the alien to make it look like they were pulling organs out of the alien being. So I think there's very good evidence that this alien autopsy video is a fake, that it does not accurately portray a real alien autopsy. Ultimately, when it comes down to the question of UFOs, I do not believe that scientists have been presented with the extraordinary evidence that's required to back up the extraordinary claim. In fact, I think it is far more likely that the images, the movies, the videos that we have seen of UFOs are being created by people who are intentionally trying to deceive us. And occasionally, you will see videos of things where people are not intentionally trying to deceive us, but they themselves are being deceived by their own preconceptions. As an astronomer, I can tell you that I spend far more time outside at night under the sky than the vast majority of people, and I have never seen anything in the sky that leads me to believe that we are being visited by an extraterrestrial intelligence. In my career, I've never seen any evidence, solid evidence, that leads me to believe that we are being visited. Well, why is it then that aliens might not visit us? Why is it that aliens don't travel across the galaxy? And the answer to that might be that spaceflight among the stars is difficult. Let's do an example, and let's take an example of a trip to our nearest star system other than our sun, and that is the Alpha Centauri star system. So this is a picture of the southern sky. This is the beautiful Southern Cross in the southern sky. 3 bright stars and a moderately bright star make up Crux, or the Southern Cross. And just to the side of the Southern Cross are Alpha and Beta Centauri, the 2 brightest stars in the constellation of Centaurus the Centaur. Alpha Centauri is one of the brightest stars in our sky. And it is one of the brightest stars in our sky because it is closer to us than any other star system. So Alpha Centauri is at a distance of 4.4 light years away. How long would it take us to travel there? Well, the fastest spacecraft that we have right now, the Voyager 1 spacecraft, I should say the fastest spacecraft that's leaving our solar system right now, is the Voyager 1 spacecraft, and it's traveling about 17 kilometers per second. That's a little over 10 miles per second. We could easily conceive of building a spacecraft that could travel about 30 kilometers per second. We could make a very lightweight spacecraft. We could have a flyby of Jupiter in the outer solar system to add a little bit of speed to that spacecraft. I think with the chemical rockets we have today, we could easily build a spacecraft that could escape the solar system at 30 kilometers per second. That is 0.0001 times the speed of light, or 0.01% the speed of light. At that speed, it will take us 44,000 years to get to the distance of Alpha Centauri. With the technology we have today, the nearest star system, not the other side of the galaxy, I'm talking about the nearest star system other than our sun, it would take us 44,000 years to get there. Now, imagine that we develop a technology that allows us to build a spacecraft that could go 10 times faster. I don't really see that we have that technology right now. We have ways to improve on the technology, on the propulsion systems that we have today, but I don't see us having a propulsion system that could let us go 10 times faster. But imagine that we develop one that can go 10 times faster than our fastest spacecraft today. That would be 300 kilometers per second. 300 kilometers per second, that's about 180 miles per second. That is 0.1% the speed of light, and at that speed, it would still take 4,400 years to get to the nearest star. What this means is that you and I will not live to see the day that humans travel to the nearest star. We will not even live to see the day that a robotic explorer travels to the nearest star, because the travel time to even the nearest star is measured in thousands of years. Now imagine that our great-grandchildren invent a technology that can go even faster than that. It can go 100 times faster than we can go today, and that would be 3,000 kilometers per second, or 1% the speed of light. At 1% the speed of light, it will take you 440 years to get to the nearest star. Now that's 100 times faster than we can do today, and even our great-great-grandchildren who develop this technology, they won't live long enough to see the day that their robot makes it to the nearest star, because the travel time is still 440 years. Now imagine that their great-great-grandchildren develop a technology that can go 10 times faster than that. It can go 10% the speed of light. Then the travel time to Alpha Centauri is 44 years. It would take a whole human lifetime to travel to Alpha Centauri and back again. And that is if we could travel 1,000 times faster than we can travel today. And then finally, if we could travel at the speed of light, or just below the speed of light, let's say, since matter can't travel at the speed of light or faster than the speed of light, it would take our probe 4.4 years to get to Alpha Centauri. The distances between the stars are so vast that I do not see us in our lifetime, or even our great-great-great-great-great-great-grandchildren's lifetimes, making it to the nearest star. That is how difficult travel between the stars is. And maybe it's just possible that no intelligent civilization in the history of the galaxy has figured out how to do it. Maybe the travel times are so long that no one has managed to conquer the galaxy. Now, I have to say that if I were to travel to another star system, I certainly wouldn't do it in the spacecraft that we have today. This is NASA's Orion spacecraft. It is the spacecraft that will be taking astronauts to the moon, possibly taking astronauts onto Mars. It is not designed for long-term living. It is not designed for living in hundreds of years. So I don't know what, if anything, well, we certainly don't have the technology today to travel to the nearest stars, but I can tell you we would definitely not do it in a spacecraft like this. I would certainly not volunteer, and I don't think anyone would volunteer to spend decades inside of a capsule that is just barely larger than the inside of a spacious minivan. I think if we were going to travel between the stars, we'd want to do it on a much larger ship. Now, since we don't have spacecraft that are much larger, I'm going to use this as an example. On a cruise ship, I could see spending a long period of time on a ship of this size. Now, we wouldn't pack it with thousands of people like happens with a cruise company. You might only put 100 people or so on here, or maybe a few hundred people. And then you would use all the extra space inside the ship for greenhouses to grow the food that you're going to need to eat, and places to recycle your air and your water and your oxygen and all the things that you'll need to stay alive. I think you could imagine taking something like this. You might get volunteers who would be willing to spend the rest of their lives on a ship like that to travel to the nearest stars. But here's another problem with interstellar spaceflight, is that to accelerate this ship to 1% the speed of light. Now remember, at 1% the speed of light, it's going to take it 440 years to get to the nearest star. At 1% the speed of light, it takes as much energy as all the energy that the United States uses in 4.5 years. That is all the fossil fuels that we burn, all the nuclear energy, all the wind energy, all the geothermal energy, all the water power, everything. All of the fuel, all of the energy that we use in 4.5 years would have to be dedicated just to get this ship up to 1% the speed of light. How we pack all that energy into a ship this small, I don't think is possible. I don't even think it's conceivable with the technology that we have today. But not only that, that's a phenomenal amount of energy. Think of the cost of just of the energy alone that it would take to get this ship up to 1% the speed of light. And here's the thing. At 1% the speed of light, it takes you 440 years to get there. When you get there, you need to slow down. It takes just as much energy to slow down when you get there. If we're ever going to travel amongst the stars, I think it will be done slowly. I think it will be done in ships that you might call generation ships. Spacecraft that are miles long or miles wide and tens of miles long, where we build on the inside of the spaceship essentially a miniature Earth. And when people leave on this spaceship to travel to the nearest stars, they know that they are not going to live to see the day. They are not going to live to see the day when the spacecraft makes it to the nearest stars. In fact, they know that their great-great-grandchildren won't live to see the day that the spacecraft makes it to the nearest stars. Because with a giant ship like this, the travel time might be hundreds, if not thousands of years. You might get on the spaceship realizing that it is your great-great-great-great-great-great-great-great-grandchildren that will finally reach the stars. But I don't know that we certainly don't have the technology to build this today. I don't know that we will ever have the technology to do this. And I don't know that we would ever marshal the resources to build a ship of this size to travel between the stars. Maybe traveling between the stars is so hard that no intelligent civilization has ever figured out how to do it. And that's why no one has conquered the galaxy. But it also doesn't answer the question then, why haven't they tried to communicate with us? Why haven't we heard communication across interstellar distances? And the answer to that is communication across interstellar distances is actually also incredibly hard to do. So the first thing is, there is the whole electromagnetic spectrum. If we're going to communicate with an extraterrestrial civilization, we will use something on the electromagnetic spectrum. And we'll do that for a couple of reasons. First of all, for some areas of the electromagnetic spectrum, it's relatively inexpensive to generate electromagnetic waves. Radio waves are a really good example. You can generate radio waves for very little cost. The second thing is they travel at the speed of light. That's the fastest speed that there is in our universe. You're not going to be able to generate anything that can travel faster than that. And then finally, electromagnetic waves, we know how to generate them. We know how to receive them. We know quite well on Earth how to manipulate them. So they are probably the best chance that we have of communicating with an extraterrestrial civilization. The problem is, where in the spectrum do we look to communicate with an extraterrestrial intelligence? Well, the one clue that we have is that they probably live on a planet like Earth. They probably live on a planet with an oxygen atmosphere that has lots of water vapor in it. And those things limit them to either trying to communicate with us in the visible portion of the spectrum, because our atmosphere, the atmosphere of our planet, is transparent in the visible portion of the spectrum, or in the radio portion of the spectrum. But probably not any other part of the spectrum. Gamma rays, X-rays, and ultraviolet light do not make it through our atmosphere. Infrared light is blocked by water vapor in our atmosphere. So if they're going to communicate with us, they'll likely either use visible light or radio waves to do it. Now, that narrows down the electromagnetic spectrum. It doesn't help us tremendously because there's still a lot of the spectrum that we need to search. I think it's most likely that they'll try and communicate with us using radio waves. Radio waves have the advantage that they are inexpensive to create. You can generate vast amounts of radio waves for small amounts of money, at least small when we're talking about the sizes of whole planets. This is the Very Large Array in Socorro, New Mexico. It is a giant array of radio telescopes on the plains of San Agustin in New Mexico. Now, an important thing to know about this telescope that we're looking at is that it is not routinely used for searching for extraterrestrial communications. In fact, it's hardly ever used for that purpose. It is a radio telescope that is used by radio astronomers. There are lots of objects in the universe that give off radio waves. Black holes, for example, give off radio waves. Individual atoms, like hydrogen atoms, give off radio waves. Molecules, as they rotate and vibrate, give off radio waves. And by using giant radio telescopes like this to receive and amplify and analyze those radio waves, we can learn about the distribution of hydrogen in our Milky Way Galaxy, the distribution of molecules, which can be used to probe places where stars are forming. We can even use it to study what's going on in and around black holes. The reason I bring this up is that the Very Large Array is famous because it was the backdrop for the movie Contact by Carl Sagan, or the book Contact by Carl Sagan. In the movie, they have Jodie Foster starring as Ellie Arroway, the main character. She's an astronomer who searches for extraterrestrial broadcasts, and she's using the Very Large Array to do that. You should know that that is not how the Very Large Array is used. It makes a great backdrop for a movie, but in fact, the telescopes are not used that way. The second thing about the movie is you'll see that Ellie Arroway is listening to the radio transmissions, and that is not what radio astronomers do. Radio waves are not sound waves. Radio waves are electromagnetic waves. And electromagnetic waves, if you convert them to sound, they don't make any sense. Astronomers use computers to analyze the radio waves that we pick up from space. We do not use headphones, but using headphones was a great tool to build some suspense in the movie. It's a lot more interesting to see her listening to headphones than just sitting there analyzing data on a computer, as radio astronomers do. So why is it that interstellar communication might be so hard? Well, the answer is what we are looking for is a needle in a haystack. And the cosmic haystack is that we don't know what or how the extraterrestrial civilization is trying to communicate with us. Take your cell phone, for example. Your cell phone works quite well because the engineers who designed the cell phone worked with the engineers who designed the cell tower, who worked with the engineers that designed our phone system, who worked with the engineers that designed the other cell phone system that you interface with, who worked with the engineers that designed the cell phone of the person you're going to talk to. Those engineers were all able to get together and they agree on the frequency that you're going to broadcast on. They agree on how powerful your signal needs to be. They agree on how you're going to encode information on the radio signal that your telephone sends. The problem for extraterrestrial civilizations is we don't know any of these things. And searching all of the possible parameters is literally like searching for a needle in a haystack. We don't know which direction to search in the sky. We don't know whether to search over here or over here or over here. So in fact, in order to determine this, we have to search the whole sky. We don't know how deep to search. That is, we don't know the strength of their signal. Is their signal going to be strong, in which case we don't have to look at any one point in the sky for a long time? Or is their signal very, very weak, in which case we have to spend a long time staring at that one point in the sky? And that means it might take us millions of years to cover the whole sky. We don't know the frequency that they're broadcasting on. What channel in the radio spectrum are they sending their signal on? So we're forced to search across about 10 billion different channels. We don't know the bandwidth of their signal, how wide their signal is. And in order to best detect it, we need to match our search for the bandwidth of the signal they're sending. Radio waves can oscillate up and down or side to side or in a circle. We don't know how, and it's called polarization. We don't know how they've polarized their signal. We don't know how they've encoded information in it. And we don't know when they turn their transmitter on. For all we know, as Carl Sagan said, they turn their transmitter on every second Tuesday of the month for an hour at a time. You know, you might say that sounds silly. Why would they do that? Well, they might do that because they're broadcasting to many different stars in the sky. And they might broadcast to us for just a few minutes or just a few hours once a year or once every few years. What if we're not looking in that part of the sky at the moment that they broadcast? Or what if they live on a planet like the Earth that's rotating around, which means that they can't see an object in the sky for half of the day? So their transmissions might be turning on and off. And since we don't know when they're turning on and off, we don't know when to look. There are so many possibilities that it makes finding an extraterrestrial signal quite difficult. In addition, we've only had the technology to do this for about the last 50 years or so. And that means when it comes to being an intelligent extraterrestrial civilization that can use radio waves to transmit across long distances and receive signals from long distances, we are a newcomer in the history of the galaxy. We are literally a newborn intelligent civilization. Because imagine a star 100 light years away. Our signals that would have been broadcast from the Earth back in the 1950s, let's say, or 1960s, about 50 years ago, they are only halfway to that star. It's going to take another 50 years for the signal to get to that star. And then if there's somebody there on that star that responds to us, it'll take their signal 100 years to come back. The average star that you see in the night sky is many tens or hundreds of light years away. Round-trip communication with them will be extraordinarily difficult. We will ask a question, and it could take hundreds of years to get an answer. So there are many reasons that communication could be difficult. Maybe they're signaling, and we don't know how to listen. Maybe they're signaling, and we don't know what frequency to listen on. Maybe our search strategy is wrong. Maybe their signal is already there, and we don't recognize it. Maybe we just haven't listened long enough. Now, there are observatories that are listening for extraterrestrial communications. Right now, the Green Bank Observatory's Green Bank Telescope in Green Bank, West Virginia, is spending part of its time searching for extraterrestrial intelligence as part of the Breakthrough Listen project. So, an interesting question comes up then. Maybe everyone is listening and no one is transmitting. And the reason to think this is that transmitting can be expensive. To build a radio telescope like this and operate a powerful transmitter that's transmitting millions of watts of energy, that would take lots of money. And because it's so expensive, we're not doing it. Now, we are unintentionally sending radio waves out into space. We are sending FM radio waves from both our television and our radio broadcasts into space. When we communicate with distant spacecraft, we're sending very powerful signals out into space. In the northern hemisphere, we have huge radar installations up in northern Alaska, northern Canada, for example. These radar installations are looking for nuclear missiles coming over the pole, and those radar are sending tremendously strong signals out into space. But no one on Earth is intentionally broadcasting. In fact, in all of human history, we've only done it a couple times. One of the times that we've intentionally broadcast a signal was at the rededication of Arecibo Observatory. And this is the first transmission that humans sent intentionally into space. And it was sent towards a globular cluster, a cluster of about 130,000 stars, about 100,000 stars, called Messier 13, about 25,000 light years away from us. It includes a pictograph or a pictogram of the Arecibo telescope, a pictogram of you and me, of what a human being looks like, the DNA molecule, some interesting molecules, some atoms, and then the numbers 1 to 10. And the hope is that when this transmission reaches the globular cluster Messier 13, an intelligent civilization will recognize this. They'll be able to decode it, and they'll learn a little bit, not much, but a little bit about you and me and the telescope that sent it. That cluster is so far away that it's going to take 25,000 years for our signal to get there. And if they hear it and respond, it's going to take their response 25,000 years to come back. That's right. We have to wait 50,000 years for a response to that signal that was sent out. For a few more times in human history, people have sent signals like this into space, but for the most part, we're not doing it. So maybe the reason we don't know of extraterrestrial intelligence is that no one is broadcasting because everyone is listening. There's another reason you may not want to transmit, and that's because transmitting could be dangerous. When I think of aliens, I often like to think of the movie E.T., the extraterrestrial. E.T. was cute. He was friendly. He had that finger that would light up, and if you were sick or ill, he could use that finger to heal you. He wasn't violent. He was curious. It's a wonderful movie, by the way. If you haven't seen E.T., I think it's a fantastic movie. You should see it. But the extraterrestrial is one view of what extraterrestrials might be like. On the opposite end of the spectrum is Independence Day, another great movie. Now, for those that haven't seen it, the tagline for the movie tells you everything you need to know. You can see here at the top of the movie poster, the question of whether or not we are alone in the universe has been answered. In the movie, on July 4th, Independence Day, the aliens show up, and the tagline says, "Don't make plans for August." When these aliens show up, they are so far in advance of us that they view us as nothing more than you and I possibly view the ants on the earth. And they go ahead and they try and exterminate us so that they can take over our planet. And it's a great movie. It's a fantastic movie. I love Independence Day. But I do have to say the ending of this movie is completely implausible. But and I won't give it away, so I won't give no spoiler alerts here. But in any case, if you haven't seen Independence Day, you should see it. But this is another view. So the question is, what will aliens be like? Will aliens be like E.T. or will they be like Independence Day? And the answer is, I don't know. I have no idea what the aliens will be like. I can tell you this, though. If human history and human evolution is any guide, every time an advanced human civilization came across a less advanced human civilization, it has ended in disaster for the less advanced human civilization. And I am concerned that the drivers of evolution that drive you to survive above all else will drive extraterrestrials in the same way that it has driven human beings to dominate the planet, but also to end up in a situation where we treat other living things, and in fact, through most of human history, other human beings as less than human, and end up with many of the disasters that we see on our planet today. I would be concerned if aliens show up that they will be far more like Independence Day than the extraterrestrial. Well, now we've discussed why communication might be difficult and why spaceflight might be difficult. Let me now address the question that maybe the evolution of life is the problem. Maybe life itself is rare. Maybe we live on a magical planet that happens to be extraordinarily rare in the galaxy. And there are lots of reasons to believe this. Planetary system could be a dangerous place. And what we mean by that is that you could get wiped out by an asteroid. There are lots of reasons to believe that there are lots of ways, I should say, in a solar system for life on a planet to get wiped out. There are other reasons to think that the Earth might be unique. The Earth has a system of plate tectonics. Turns out we are the only planet in our solar system that has plate tectonics. And plate tectonics have been absolutely essential to evolution on the surface of the Earth. What if you have a world without plate tectonics? Do you not get the drivers of evolution that you had here on Earth? Our moon is unique given its large size compared to our planet. It might be that tides were very important for life and very important for evolution in the early history of the Earth. Could it be that if you don't have a large moon like we have, that you don't end up with intelligent advanced life? Maybe the genesis of life is rare. Maybe life doesn't happen very often. Maybe technological process is not inevitable. Maybe you get stuck at, say, the technological advancement that we had during the time of the Roman Empire or during the Bronze Age. What if you reach a level like that and then just don't advance from there? Maybe intelligence at the human level is rare because things like language is unusual. Maybe life is common. Maybe there are millions of planets in our Milky Way Galaxy that have a single-celled life and hundreds of thousands of galaxies that have plants and animals, but that human-level intelligence is very rare. All of those are possible. It's called the rare Earth hypothesis, and it states that possibly we live in a very unique place, and that the reason we appear to be alone in the galaxy is because we are, and we are alone because planets like the Earth and the evolutionary processes that took place on the Earth are extraordinarily rare. So let me sum up a little bit of where we are. We saw at the very beginning of this lecture that there are hundreds of billions of stars in the galaxy, and it makes it seem likely that life is common. And I will tell you now my opinion, and I do believe that life is common in the galaxy. I believe that single-celled life is probably very common in the galaxy. But because single-celled life was the dominant life form on the Earth for billions of years, I believe it is the dominant life form in the galaxy. I think planets with plants and animals are going to be much rarer in the galaxy because they at least for the history of the Earth so far, they have only been on Earth for a small fraction of the history of the Earth. So I don't believe the reason that we're alone is because there's not life out there. I believe that there is. So I believe that life is common. I don't believe that intelligent life in the galaxy is common. I don't believe that there are extraterrestrial species that are conquering the galaxy at this moment in time. I do not believe that we have the evidence that we're being visited by extraterrestrials. I do not believe that extraterrestrial intelligence have ever conquered the galaxy. And I think it is in part because spaceflight is so incredibly hard that no one has ever figured out how to do it. I think communication is the same problem. Communication is so hard to do across interstellar distances. That explains why we've never been contacted by an extraterrestrial intelligence. So that raises the question, what is it that prevents civilizations from conquering the galaxy? If we really are alone, what prevents it from happening? Well, Robin Hanson at George Mason University came up with an idea And let's talk about this for a second. To go from a planet like the Earth to a civilization that can conquer the galaxy, that has conquered interstellar travel, you have to make it through a number of steps. For example, you need a planet with liquid water, and then you need to form life, and that life needs to have complex biochemistry, and then you need eukaryotic life and sexual reproduction and multicellular life, and on and on and on and on. There are many different stages that you have to go through until you become a civilization that can do interstellar colonization. Now, I don't pretend to believe that these are the correct steps. I don't know that these are the right steps. I certainly don't know that this is the right number of steps. We don't know how many steps you have to go through to get there. We just know that there are a number of hurdles that you have to overcome over time, a number of things that you have to accomplish to finally get to that state where you are capable of interstellar colonization. You can imagine a planet just like the Earth that forms out there, and it has liquid water on the surface and forms life and the complex biochemistry and eukaryotic life and sexual reproduction and multicellular life and the next step and the next step and the next step and the next step. But then it gets stuck, that there's a step that it just can't get beyond. And you can imagine that it can't get beyond that step because that's a really hard step to get past. That is a step that is so hard that many civilizations don't get past that step. They end up getting stuck there. In fact, that step could be so hard that most civilizations end up getting stuck there. And Robert Hansen introduced the idea of something he called the Great Filter. The Great Filter is a step that is so hard that it prevents the majority of civilizations from reaching interstellar colonization. And I shouldn't even say civilizations. It prevents the majority of Earth-like planets from interstellar colonization. That great filter, it might be the formation of life. Maybe the formation of life is the great filter. Maybe it's complex biochemistry. Maybe it's some step that's in here that I haven't labeled. Maybe it's on another step. The great filter is a step that is so hard that maybe most civilizations, most planets get to the great filter and they don't get beyond it. In fact, a really big concern is what if the great filter is such a difficult step that nobody gets beyond it? That in the whole history of the galaxy, there could have been millions of intelligent civilizations, and we are just one of them. But no one has ever gotten past the great filter because no one, to our knowledge, has ever achieved interstellar colonization. Maybe that step is that hard. And then the question we need to ask ourselves is, where are we today? Is the great filter behind us, or is the great filter in front of us? Have we already successfully passed the great filter, or is it still to come? Because if the great filter is behind us, if we have already passed it, then we are likely to achieve interstellar travel. Now, unfortunately for people like me who would dearly love to travel between the stars, I've spent my life studying astronomy and studying the galaxy and the universe that we live in. I would give anything to travel through the galaxy and see up close and in person those things I have studied from afar. It's unfortunate for me that I didn't get to live in the age when we are an interstellar species that can colonize the galaxy. But if the great filter is behind us, we've gotten past the hard step, and now it's just a matter of time before we achieve interstellar travel. But what worries me, and what literally keeps me up at night, is what if the great filter is in front of us? What if the universe is telling us something really important? That there's a great filter out there, and it prevents civilizations from colonizing the galaxy, and we haven't reached that great filter yet. What if that great filter is nuclear war, or overpopulation, or global warming, or biological warfare, or a pandemic, or the exhaustion of cheap fuel, or civil and social and economic strife? What if the great filter is not just in front of us, but it's immediately in front of us, that we're staring at it right now? That every intelligent civilization that finally develops the ability to travel in space, and every civilization that develops the ability to communicate between the stars, they also develop the ability to destroy themselves. What if the great filter is right in front of us? What if millions of civilizations have existed in the Milky Way Galaxy, and not one of them has figured out how to get past the great filter. Does that mean that we won't figure out how to get past the great filter? That we will get wiped out by the great filter? What concerns me is that I've been asking the wrong question the whole time. I've been asking the question, are we alone? And maybe I should have been asking the question, how long do we have? Is the great filter in front of us? What is the great filter? How are we going to get past it so that we can become a civilization that can have interstellar colonization and survive on other worlds so that we can survive for the long term? What allows me to sleep at night is working with students at the University of Virginia, working with youth in scouting, and working with youth in the Virginia Space Grant Consortium. Because you are the leaders of the future. You will be the political, the social, the scientific, the economic leaders of our future. Take the lesson that the universe is telling us. Intelligent life is rare, and it might very well be rare because intelligent life destroys itself. Keep that in mind as you face the world's problems. Solve the world's problems. Do the right thing. Do the just thing. Do the thing that will help humanity survive. Help us get over the great filter. Because ultimately, if we are the only intelligent civilization in the galaxy, if it's just us, it seems like an awful waste of space.